So this is T. Kushi from ITA, and my topic for concept video for physics is star to delta conversion. So star to delta conversion, we know the basic of series, parallel or combo of series and parallel connection. But another little bit complex configuration is star to delta configuration. The three-phase networks have three wires, and usually the networks are connected in star and delta configuration. The three-phase supply or the load connected in either formation can be converted into its equivalent counterpart. We use such conversions to simplify the mathematical calculations required for circuit analysis of a complex electrical network. So you can see in the picture the conversion of a delta to star or via star to delta conversion. Delta connected network. The delta connected network is formed when three network branches or impedances are connected to form a loop in such a way that their heads are connected to the tails of the adjacent branch. The resulting network forms a triangle shape that resembles a Greek letter delta, which is why it's named after it. It is also known as pi network because it resembles the letter after rearranging the branches. So generally, delta network is in the shape of a triangle, and after its rearrangement, it looks like the shape of pi network. So it is also called as pi network. You can see the structures of delta network, which is also called as pi network, in the picture given below. Star connected network. So coming to the star connected network, the star connected network is formed when three branches or impedances are connected together at a common point. The other ends of the branch networks are free. The resultant shape resembles the letter Y, which is why it is called as Y or Y connected network. And it is also known as T connected network due to its shape after rearranging the network branches. So here again in the picture you can see the star network, and the star network is also called as Y network because it is in the shape of Y, and the star network is having free ends, and after the rearrangement you can see it is formed in the shape of T, in the letter T, so it is also called as T network. And the main difference between star connected network and delta connected network is delta connected network has closed ends, whereas coming to the star connected network, it has free ends. That is one of the difference between star connected and delta connected network. So now let us discuss about the conversion of star network into an equivalent delta network. This conversion is called as star to delta conversion. So to convert a network into a star to delta conversion, first we have to derive the formulas or equations which are required for the conversion. So for deriving the formula of conversion of star to delta conversion, before that you have to know the formulas of delta to star conversion, which are as follows. So we got the resistances of star network from delta network as RA is equal to R1 R2 by R1 plus R2 plus R3. This is our equation 1. And RB is equal to R2 R3 by R1 plus R2 plus R3. This is our equation 2. And RC is equal to R3 into R1 by R1 plus R2 plus R3. This is our equation 3. So here we have derived three equations, that is, which are the equations which we got from star network from delta network. That is, in delta to star conversion, we derived these three formulas RA, RB, RC. So these are going to be our equations 1, 2 and 3 as follows. So delta network resistances in the terms of star network resistances. So let us manipulate the above equations that are, what are the above equations that are RA, RB, RC are equation 1, 2, 3. So we are going to manipulate these equations in order to get the resistances of delta network in terms of resistances of star network. So multiply each set of two equations and then add them. So we are going to multiply each set of two equations, and finally after multiplication of those sets we are going to add them. So RA plus RC plus RA is equal to, after multiplication and adding, you are getting it as R1 R2 square into R3 plus R2 into R3 square into R1 plus R3 into R2 into R1 square by R1 plus R2 plus R3 whole square. Now, in the next step, you're going to take R1, R2, R3 as common. Then the equation will be RB plus RC plus RA is equal to R1, R2, R3 into R1 plus R2 plus R3 by R1 plus R2 plus R3 whole square. So here we are going to cancel one R1 plus R2 plus R3 in the numerator and denominator. Then our final equation will be RB plus RC plus RA is equal to R1, R2, R3 by R1 plus R2 plus R3. So this will be our fourth equation, that is equation number 4. So now we have derived equation number 1, equation number 2, equation number 3 and equation number 4. Now in the next step, by dividing equation 4 with equation 2, you are going to get the value of R1, that is R1 is equal to RB plus RC plus RA by RB. Then R1 becomes R1 is equal to RC plus RA plus RA by RB. Now in the next step, you're going to divide equation 4 with equation 3, similarly as it is done in the above equation. So you're going to get the value of R2, that is R2 is equal to RA plus RB plus RB by RC. And in the next step, you're going to divide equation 4 with equation 1. So similarly as the above equation, how you solved, in the same way we are going to solve and derive R3. R3 is equal to RB plus RC plus RC by RA. So in this slide, we'll know that we are going to divide equation 4 with all the three equations. That is, equation 4 is divided with equation 1, equation 2 and equation 3 in order to get the values of R1, R2, R3 respectively. So by using the above relations, we can find the resistance of delta network from the resistances of star network. In this way, we can convert a star network into a delta network. So final equations for star to delta conversions are as follows. R1 is equal to RB by RC plus RB plus RA, and R2 is equal to RC by RB plus RA plus RC, and R3 is equal to RC by RA plus RB plus RC. So these are the three equations required for the conversion of a star network to a delta network. That is R1, R2, R3 are the three equations which are needed. So in this picture, you can see the formulas which are needed to convert a star network to a delta network or a Y-lettered network to a delta network. So to understand in a better way, let us see some examples for the conversion of a star network to a delta network. So our first example is, let us calculate the resistances of delta network which are equivalent to the star network as shown in the figure. So here you can see the figure. The star network is named as ABC and even the delta network is named as ABC. So the star network is going to be converted into a delta network. So here the resistances of star networks are RA is equal to 6 ohms, RB is equal to 18 ohms and RC is equal to 3 ohms. So by using the formulas which we have derived earlier, that is formulas of R1, R2, R3, we are going to find the resistances of delta network and we are going to convert a star network into a delta network. So given resistances of star network are RA is equal to 6 ohms, RB is equal to 18 ohms and RC is equal to 3 ohms. And we know the following relations of the resistances of delta network in the terms of resistances of star network. So to get the value of R1, the formula is R1 is equal to RC plus RA plus RC RA by RB. And to find R2, it is RA plus RB plus RA RB by RC. And to find R3, it is RB plus RC plus RB RC by RA. So now we are going to calculate the R1, R2, R3 values by substituting the values of RA, RB, RC in the above equations. So R1 is equal to 3 plus 6 plus 3 into 6 by 18. You're getting R1 as 10 ohms and R2 is equal to 6 plus 18 plus 6 into 18 by 3, that is 60 ohms, and R3 is equal to 21 plus 9, that is equal to 30 ohms. So we got the resistances of delta network as R1 is equal to 10 ohms, R2 is equal to 60 ohms, and R3 is equal to 30 ohms, which are equivalent to the resistance of the given star network. So let us see another example. So the main difference between the before example and in this example is that here, as you can see, the resistances in the star network are same. So all the three resistances are same. All the resistances values are 10 ohms, 10 ohms and 10 ohms. So we are going to check when we are going to convert an equal resistance star network into a delta network, whether the resistances in delta network will be equal or not. So let us solve this problem. So star to delta conversion. So RAB. So we have named the network of delta as RAB, RCA and RBC. These are the resistances of delta network. And we are going to find these values by substituting RA, RB, RC values in the respective formulas. So RAB is equal to RA, RB plus RB, RC plus RC, RA by RC. That is, after all calculation, you're getting the value as 30 ohms. And RBC is equal to RA, RB plus RB, RC plus RC, RA by RA. So after all the calculations, after substituting RA, RB, RC values, you are going to get RBC value as 30 ohms. Coming to RCA, RCA is equal to RA-RB plus RB-RC plus RC-RA by RB. So here also, after substituting all the values respectively, you're going to get RCA is 30 ohms. So as you observe, after substitution of all the values and finding the values of resistances of delta network, you can see that RAB is equal to RBC is equal to RCA is equal to 30 ohms. So in this problem, we got to know that when the star network is having equal resistances and it is converted into a delta network, in the delta network also the resistances will be equal. As you can observe in this example, we got all the resistance of delta network as 30 ohms. That is, RAB is equal to RBC is equal to RCA is equal to 30 ohms. And coming to the conclusion, why do we use star to delta network, or why is it important to use, or why it is needed? So in many cases, to solve complicated circuits, star to delta conversion or delta to star conversion are very useful. This will minimize the length of the sum, and it will also reduce the time period. So we can save our time and we can save even the time that is taken to solve, and the complexity of the problem is also reduced. If you're not using these problems or these conversions, and if you want to solve a complicated circuit or a complicated network, it takes a lot of time and it needs a lot of concentration, and it needs lot of time as well. So in such cases, it is better to use such type of conversions, that is star to delta conversions or delta to star conversions. This will minimize the complexity of the problem, and it will be easy to solve a particular problem even though it is very complicated, and it takes very less time, and it is very easy to calculate because we'll have direct formulas for the conversions. So the conclusion is that to solve complicated circuits in an easier way and to save our time, the star to delta conversions are very useful. Thank you.